Assalamualaikum warahmatullahi wabarakatuh. In this video, we are from Group 5 will explain about experiment gravimetric analysis of a soluble chloride. Firstly, the objective of the experiment is to enable students to know the steps involved in the gravimetric method. Secondly, to calculate the percentage of chloride and error percentage.
First, we need to weigh exactly 0.3 gram anhydrous natrium chloride. Transfer into a clean 250 ml beaker, add 150 ml distilled water and 10 drops of concentrated nitric acid. Then, add 0.2 molar silver nitrate using dropper while stirring slowly until the precipitation complete. Heat the beaker with the precipitate close to the boiling point with gentle stirring until the silver chloride precipitate coagulate at the bottom. Remove the beaker from the heat source and let the precipitate settle to the bottom. Test the completion chloride precipitation by adding few drops of silver nitrate to the supernatant solution. If precipitation is not complete, repeat steps 3 to 5. Then, place the beaker in the dark and let it sit at least 1 hour before filter.
While waiting, whisk the filter paper. Filter the precipitate and wash the precipitate with about 20 ml of diluted nitric acid 1 versus 1000 to water. Collect the last washing solvent containing diluted nitric acid 5 ml of filtrate and test with diluted hydrochloric acid. If the solution turns cloudy, repeat steps 8 to 9. Transfer filter paper with precipitate into watch glass. Dry in an oven at 100 to 200 degrees Celsius for 30 minutes. Let it cool to room temperature and desiccator and wait.
Based on the data obtained, calculate the mass of the chloride in the sample obtained. Firstly, calculate the mole of AgCl, which is mass divided by molar mass. 0.3708 divided by 143.32 equal to 5.099 multiplied by 10 to the power of negative 3 mole. So from the equation, 1 mole of AgCl produce 1 mole of Cl minus. So 5.099 multiplied by 10 to the power of negative 3 mole AgCl will produce 5.099 multiply the power of negative 3 mole Cl minus. Next, calculate the mass of the chloride, which is mole multiplied by molar mass of the Cl minus. 5.099 multiplied with 10 the power of negative 3 mole multiplied with 35.453 gram per mole equal with 0.180 gram, which is the actual weight. Also can calculate the actual weight of the chloride, which is mass of NaCl multiplied with molar mass of the chloride divided by molar mass of NaCl. 0.3076 gram multiplied with 35.453 gram per mole divided by 58.44 gram per mole equal with 0.1808 gram or actual weight. B. Calculate the yield percentage and the percentage of error obtained. Percentage yield, which is actual yield divided by theoretical yield multiplied with 100%. 0.1808 gram divided by 0.1866 multiplied with 100% equal with 96.9%. The percentage of the error obtained is actual value minus theoretical value divided by theoretical value multiplied with 100%. 0.1808 gram minus with 0.1866 gram divided with 0.1866 gram times with 100% equal 3.5%.
For the discussion, firstly, what is the function of using the concentrated nitric acid in this experiment? Basically, it is to maintain a high electrolyte concentration. Also, the importance of using the concentrated nitric acid is to prevent peptidization during the washing step. Secondly, what is meant by the supernatant solution? We can describe supernatant solution is the clear liquid that lies above the solid residue after precipitation. The liquid is normally free of precipitate and has a lower density. Thirdly, why washing solution turns cloudy when tested with hydrochloric acid? The chlorine with the negative charge is determined by precipitating with silver nitrate reagent. The filtrate is tested for silver with positive charge only. How it is tested? By adding sodium chloride or dilute hydrochloric acid. So, the summary, if the solution becomes cloudy, it means the washing process is not complete yet. Just that, washing is continued until the test is negative. For the next question, what will happen if the sample exposed to light and not kept in the dark? If the sample exposed to light, it will undergo one process called photodecomposer, where the silver chloride will turn into elemental silver and chlorine gas. This type of chemical reaction is called photolytic decomposition reaction. For the colors of each chemical component, the silver chloride is white and the silver metal is grey. The chemical reaction involved in the process is shown as below. The fifth question is, why desiccator used during cooling? There are three reasons why desiccator was used. The first reason, to prevent the sample or beaker from gathering moisture in the middle of cooling. The second reason, the interior of the desiccator is dry due to the desiccant at the bottom. And the last reason, the desiccator is sealed to keep the moist air at the outside from getting inside.
Question 6. Washing with water will cause baptizing. What is baptizing? Baptizing is the process of transforming a freshly prepared precipitate to a colloidal solid. How it process come? By shaking it with a small amount of electrolyte. Why baptization cannot occur when dilute in nitric acid is used? It because the dilute of nitric acid maintains a high electrolyte concentration, and also the AgCl particles stay cooled together. Question 7. Safety precaution to be taken when doing the experiment. Firstly, transferring all of the liquid should be in small quantity as possible. Second is precipitation should be practically complete and free from contamination.
The purpose of this lab was to determine the percentage of chloride and the error percentage obtained from the sample by using gravimetric analysis method. The lab was very long and tedious, but after completing the procedure, it was determined that the percentage of chloride was 96.89%. This experiment was done by mixing the dried precipitate and converting the grams of that precipitate into moles and comparing molar ratios to turn the chloride into grams. The variation in the percentage of chloride in the known sample may have been resulted by impurity in the sample or due to the random error during experiment. The percentage of chloride could then be found as well as the percentage error, which is turned out to be 3.21%. This indicates that the lab did not go horribly, but that there were still errors made. A few factors that could have contributed to the error in the lab are not heating the filter paper long enough, not checking the precipitate for completeness, and not filtering all the precipitate through the filter paper. The washes of precipitate were necessary because we had to make sure all of the precipitate was out of the solution. If it turned cloudy, that is because there was still precipitate in the solution. An incomplete transfer of precipitate from the beaker to the funnel will result in lower chloride content than expected in the calculations.